monstrous black holes that consume everything in their immediate vicinity, gigantic asteroids that chase through space at an insane speed, and bizarre exoplanets that resemble glowing, hellish worlds. The various formations and structures in the universe are as fascinating as they are diverse. No less exciting, however, are those majestic cosmic clouds that experts refer to as planetary nebulae. What characterizes these breathtaking structures, and which spectacular planetary nebulae have already been added to the star charts? We'll show you now. Want to learn more about the groundbreaking discoveries and fascinating spectacles in the universe on a regular basis? Then remember to subscribe to our channel and click on the bell to never miss one of our videos again. Feel free to show us you like our posts about the greatest mysteries of the cosmos with a thumbs up. Mysterious Nebula NGC 6891. It's September 22, 1884, and Scottish astronomer Ralph Copeland adds a remarkable entry to the ranks of astronomical discoveries. At that time, however, the researcher could not have guessed the scope of this fascinating planetary nebula, which was given the scientific designation NGC 6891. However, thanks to our modern technical means, more precisely thanks to the work of the Hubble Space Telescope, we now know how the cosmic beauty of the gas formation is displayed in all its glory. In the spectacular Hubble images, we can see in detail the multi-layered structure of the object, which is located nearly 12,000 light-years away in the constellation Dolphin. NGC 6891 consists mainly of gas ionized by a central white dwarf. The term ionization describes a process in which one or more electrons are removed from an atom or molecule. As a result of this process, the atom or molecule remains as a positively charged ion. This process also releases energy in the form of light, which brightly illuminates the breathtaking nebula. Furthermore, the images taken by Hubble show the complexity of the inner structure of the planetary nebula. Among other things, we see a spherical outer halo, which is expanding much faster than the inner layers of the nebula. The two inner regions, which have the shape of ellipsoidal shells, also appear to be oriented differently. Based on the nature of the individual components of the structure, experts concluded that the outer halo is estimated to be 28,000 years old, while the inner components are less than 5,000 years old. This suggests that the central white dwarf underwent a series of eruptions at different times. Planetary nebulae. The common name of such astronomical objects is extremely misleading. In fact, these stunning nebular formations have nothing to do with planets. Actually, the corresponding naming is historical. At the time when the first planetary nebulae were added to the star charts, they appeared mostly spherical when viewed through telescopes, which made them look remarkably like distant gas planets. In reality, however, these objects consist of a central old star and a surrounding envelope of plasma and gas, which the glistening bright celestial body ejected at the end of its evolution. Typically, the predicted lifetime of planetary nebulae is no more than a few tens of thousands of years. Compared to the previous stellar life, which can last several billion years, this period therefore seems extremely short. However, the just presented NGC 6891 is by far not the only planetary nebula in our home galaxy. So far, about 1,500 of these breathtaking objects have been identified in the Milky Way, and the nebulae play an important role in the chemical evolution of the galaxy. According to this, the material ejected by the dying stars enriches the interstellar matter with heavy elements such as oxygen, nitrogen, and carbon. In fact, planetary nebulae in distant galaxies are often the only observable formations that can be used to draw important conclusions about the chemical composition of the corresponding cosmic assemblage. Diverse forms. Given the fascinating images of NGC 6891 and the observational errors of the past, one might think that planetary nebulae typically have a spherical shape. However, A look at the images of the many other planetary nebulae, also made by the Hubble Space Telescope, proves that this is not the rule. In fact, only 20% of all known planetary nebulae are approximately spherical. The majority of these objects, on the other hand, are far more complex, and their structures can take a wide variety of forms. The reasons for this fascinating variety of shapes are not yet known. The discussed explanations are mainly based on the effects of magnetic fields, companion stars, and stellar winds. But let's take a closer look at the breathtaking variety of shapes of planetary nebulae. For example, the majestic Cat's Eye Nebula in the constellation Dragon looks like a mystical, intricate object that could easily appear in any science fiction blockbuster. In fact, structurally, it's one of the most complex planetary nebulae around. As such, images taken by Hubble revealed a wide variety of structures in the Cat's Eye Nebula, including arcuate features, knots, and jets. The core of the nebular structure here is an O-type star, whose temperature is estimated to exceed 174,000 degrees Fahrenheit. While this glowing celestial body is about 10,000 times brighter than our Sun, it has only 0.65 times its radius. The inner main body has a density of about 5,000 particles per cubic centimeter, and the prevailing temperature there is estimated to be 17,000 degrees Fahrenheit. The outer halo has a temperature of 29,700 degrees Celsius, but its density is significantly lower. With the help of spectroscopic analyses, researchers were able to prove that the Cat's Eye Nebula is losing more and more mass due to its fast stellar wind. In detail, this cosmic mass loss amounts to 20 trillion tons within a single second. To fully understand the mechanisms that lead to the unique shape of the Cat's Eye Nebula, more research is needed. The bright areas of the nebula are thought to be caused by the interaction between the ejected material and the stellar wind. As a result of this process, X-rays are released, and the stellar wind has practically completely hollowed out the inner bubble of the structure and broken through its ends. Furthermore, it's assumed that the inner celestial body is in fact the component of a binary star system. The accretion disk, or in other words, the surrounding rotating disk, which constantly transports matter towards the center, could have been formed by the mass exchange of the two stars. However, the concentric rings around the inner nebula are an unsolved mystery. According to the current findings, these rings were ejected in intervals of several hundred years, an unusual time span that cannot be classified in known schemes. Typically, such heat-induced pulsations occur at intervals of tens of thousands of years at the outset, with smaller events typically recorded at the surface only every few decades. Other planetary nebulae. Another example that illustrates the cosmic uniqueness of planetary nebulae is called the Ant Nebula. The object in the constellation of Protractor was discovered in 1922 by the American astronomer Donald Menzel and was formed when a central red giant hurled ejected material onto its cosmic companion, a white dwarf. Since the shape of the structure resembles the torso of an ant, it was appropriately named after the small insect. In detail, this planetary nebula spreads out radiatively, with the pace of this expansion estimated at about 30 miles per second. The Butterfly Nebula, 2,100 light-years away from us, also captivates us with its cosmic beauty. Originally discovered in 1947 by Rudolf Minkowski, Hubble made high-resolution images of the structure in the constellation of the Serpent Bearer in the late 1990s. As part of the in-depth observations, experts found that the fine gas structures of the Butterfly Nebula are moving away from the central star at a breathtaking speed of 10,000 miles per second. The youngest known planetary nebula is the Stingray Nebula. Experts' observations leave no doubt that the object, which is 18,000 light-years away from us in the constellation Altair, was formed in the 1970s at the earliest. According to this, some spectra taken in 1971 still showed a red supergiant at the corresponding position. The first indications that the star, which had reached the end of its evolution, had made the transition to a planetary nebula was finally found in 1989. The tangible proof that it was indeed a planetary nebula was to be provided in 1993 with the help of the International Ultraviolet Explorer Space Telescope. In fact, This observed event was to be an astronomical milestone. In previous models, experts had predicted that the transition time of a star to a planetary nebula would be at least 100 years. However, the Stingray Nebula proved that this process can be completed in about 20 years. In more detail, the center of the nebula is graced by a binary star system. The remaining white dwarf, which emerged from the former red giant, has a presumed intrinsic mass of about 0.6 solar masses. The gravitational interaction between the white dwarf and its companion star leads to the fact that both celestial bodies are connected by a very fine gas track. Since the Stingray Nebula is, as mentioned, only a few decades old, it's accordingly still very small. In fact, its size is only about 10% of the size of other known planetary nebulae. Now it's up to you. What do you think about the fascinating planetary nebulae and the spectacular images of these formations? Just write your thoughts, suggestions, and feedback on today's video in the comments. Finally, feel free to take a look at the other exciting posts on our channel, which you can access by clicking on the thumbnails in the credits now. Thanks a lot for watching. Take care, and we'll see you next time.